Previously, we have introduced the fundamental theorem of arithmetic, which basically claims that every natural number greater than or equal to 2 can be uniquely decomposed into prime factors. Now that the prime numbers are the building blocks of positive natural numbers, it is very natural to ask, how many building blocks do we have? As one can probably imagine, in our best dream, if there are only finitely many prime numbers, then a lot of problems will be greatly simplified. Yet in this section, we show that this dream is too good to be true. Actually, we prove the following theorem, that there are infinitely many prime numbers. Again, to see why this is true, let us assume, for the sake of contradiction, that there are only finitely many prime numbers. Since there are only finitely many of them, we can enumerate all these prime numbers one by one, and denote them by P1, P2, P3 until Pn, where n is the total number of all the primes. From there, let us construct a number k, which is equal to the product of all the distinct prime numbers plus 1. Now clearly, by our construction, k is at least 2. Thus the fundamental theorem of arithmetic works, which permits us to write k as the product of all its prime factors. In particular, let p be a prime factor of k. Thus, naturally, p divides k. On the other hand, p also divides the product of all the distinct prime numbers, because p must be one of them. Thus, since p divides both parts, p should divide their difference as well, which is precisely 1. But this means p is equal to 1, which contradicts the primality of p. This finishes the proof, and we conclude that there are infinitely many prime numbers.